So next we talked about biconditionals, right? And remember, a biconditional is an if and only if statement, right? So it's a statement where both its original, the original conditional is true if P then Q, but also the converse is true, right? If Q then P. So both are true, and so you can say P if and only if Q, right? So the hypothesis if and only if the conclusion, right? And remember, it is symmetrical, so you can say it both ways. You can say if Q, or Q if and only if P, right? And remember, so we can use this double arrow here for if and only if, or we can also use the abbreviation IFF, okay? All right, so if we're given a statement, like number 7, if two segments have the same length, then they're congruent. That's true, right? And then the converse, if they are congruent, then they have the same length. If two segments are congruent, then they have the same length. That's also true. So we can say two segments are congruent, or excuse me, two segments have the same length if and only if they are congruent. All right, so that's the basic idea of a biconditional statement. So just kind of scan these examples, see if you have any questions, and email me, practice, look back through your notes, and yeah, just try to figure it out. Just try to use your resources and get help before the test, right? Because if any of these are fair game for the test, and when they come up on the test, the day of the test, I won't be answering any questions, but definitely I'd love to answer questions before the test. All right, and so just remember that a biconditional is reversible. A true biconditional is reversible. So remember, it's true for the original and the converse. And then remember that a good definition is a biconditional, right? So remember that if you can write it as a conditional and it's true, and you can write it and its converse is true, then that's a good definition. So for example, number 26, I can say if a figure is a segment, then it's part of a line. That's true. And I can say if a figure is part of a line, then it's a segment. That's true. So that's a true biconditional, and it's a good definition, right? So number 28, on the other hand, opposite rays are two rays that share the same endpoint. So if I say if a figure is an opposite ray, or if two rays are opposite, then they share the same endpoint. That's true. But if two rays share the same endpoint, they're not necessarily opposite rays, right? A counterexample would be these two here, right? I have two rays that are not opposite rays, because opposite rays would form a straight line. Okay, so this is not a good definition, whereas this one is. All right, so here's some more examples to look through. And of course, you can look through the book yourself, but just wanted to kind of run through some of these.